Hi there, this is Mr. Maney, and this lesson is 6.3 Standard Form. The essential question is, how can you write a linear equation in standard form given properties of the line, including its slope and points on the line? So this lesson is a continuation of 6.1 and 6.2, so hopefully you're pretty comfortable with writing linear equations in point slope form and also slope intercept form. That's going to be required for you to understand how to do this skill, which is writing it in standard form. Standard form was actually first introduced in the previous module, so hopefully you know what it looks like. And if you forgot, it gives you the form right here under the beginning of the Explorer, and it looks like ax plus by equals c. There are some restrictions on what a and b can equal, but right below are some examples of standard form, slope-intercept form, and also point-slope form. All three of these equations that are given are actually all the same exact line if you were to graph it. So it's a good idea to kind of look at, what do they have in common? Which one you might prefer over the other, maybe depending on what's being asked of you. So things like finding x and y intercepts, things like finding slope, and then finding additional points on the line. Okay, so we're actually going to skip this Explorer. And we're going to go directly to the Your Turn. And that's on page 263. So the first thing we're going to do is write an equation in standard form for each of the lines. So don't give us a whole lot of space here because we're going to need more than this. We have two methods to do this. And so number 4, if we have slope is -2, and then we have -7 comma -10 on the line, then the first thing we're going to do, we got two options. And so I'm actually going to put it just right up here for since we need some more space. So here's option 1. And that is we're going to write it into y equals mx plus b. That's the slope-intercept form. So I already know what the slope is. So going down back to the original problem, if my slope is -2, that's the m. If my -7 represents our x coordinate and then -10 represents a y coordinate, remember this is just one of the points on the whole line. We have an infinite amount of points, but that's one of them. I can go ahead and plug that straight into my y equals mx plus b that's up here. So let's do y is -10, m is -2, and x is -7. So we do this for the purpose of finding what b is. So we have -10 equals 14 plus b, and then subtracting 14 on both sides is going to give us b is equal to -24. So once I know my slope and my y-intercept, I can write my equation. Y equals -2x minus 24. Okay, so if my directions were to write this in slope-intercept form, I would be done. But they want us to write it in standard form. And that means we're going to add 2x to both sides and then get 2x plus y equals -24. And so this is our standard form of the equation. Okay, 2x plus y equals -24. Now here's option 2. I'm giving you these two options because you get to choose which one you want to use. This is assuming you know how to do both point slope and slope intercept. So I'm going to use a point slope form this time. Y minus y1 equals m times x minus x1. You want to try to memorize this, this equation if you intend to use it. So again, I have slope is -2 here, and then I have -7 is actually going to represent my x1, and -10 is going to be my y1. And we just plug it straight into here. So it's going to be y minus -10, which becomes y plus 10, okay, because it's minus and negative, equals -2 times x minus -7. And again, we're going to get x plus 7 there. So then I get y plus 10 equals negative 2x minus 14. Okay, so I'm going to do two things here. I'm actually going to add 2x to both sides, and I'm going to subtract 10 on both sides. And that's going to give me, if I do it over here, 2x plus y on the left side. And on the right side, negative 14 minus 10 is going to give us negative 24. So here's my standard form. And you see this matches exactly what I got up here when I used option number 1. So you will arrive at the same standard form regardless of which option you choose. Okay, so let's go ahead and try number 5. If you want to try it on your own, go ahead and pause it. So slope is 4, and we had the point negative 3 comma 0. So I'm going to do option 1 up here at the top. And that's the slope-intercept form. So I got y. I'm sorry, we know what y is, so I don't want to use y. We have 0 equals 4 times negative 3 plus b. So remember, 4 is my m, negative 3 is my x, and 0 is our y. So I have 0 equals negative 12 plus b, and therefore b is 12. So my equation in slope-intercept form is y equals 4x plus 12. And then I am going to subtract 4x on both sides to get our standard form. So I'm going to get something like negative 4x plus y equals 12. Okay, that's option 1. Option 2 is my point slope form. So that's y minus y1, which is y minus 0, equals m times x minus x1. So it's going to come out to x minus negative 3, which is x plus 3. So that 0 actually helps us out in that we don't need it anymore. Equals 4x plus 12. And look at that. That actually looks just like our slope-intercept form. Excuse me. So if I want to write this into standard form, I just have to subtract 4x on both sides, and I end up with the same thing that I have up top. Negative 4x plus y equals 12, and that's it. Okay, so these are examples when we're giving the slope and the point, and 1 point, in fact. So our next example is, what if we have 2 points given to us? And I'm only going to do one of these because the other one is going to be very similar. And in fact, the process is very similar to the 2 examples we just did. There's only one extra step at the beginning. So if we want to do either point slope or slope intercept, we have to have one important piece of information, and that is the slope. So to find our slope, this is a good one to practice because finding slope, there's a lot of ways to make mistakes there. So I'm going to call this x1 and y1, and then the second point x2 and y2. And I'm going to do my slope formula, which is subtract the y's on top. So I do y2 minus y1, and then subtract the x's, I got 2 minus 4. Okay, and so negative 3 minus negative 7 is going to give us a positive 4. And then 2 minus 4 is going to give us a negative 2. And so our slope is negative 2. So once I found the slope, then the process is exactly the same as the 2 examples that we just did, meaning that we use a slope and we use one of the points. So let's just say I choose to use this point right here, that 2 comma negative 3, and then let's choose a different color so that you don't get confused here. I'm going to use point slope form. So y minus y1, which means y plus 3, okay, because I did y minus -3 equals -2 times x minus x1, or x. Remember, I'm calling this x1 and y1 here, so I'm ignoring my other point. And then from here, I got y plus 3 equals -2x plus 4. And so I'm going to do two steps here. I'm going to actually add 2x to both sides here, add 2x. And then I'm going to subtract 3 from both sides. So without showing that step really, I'm just going to add the 2x and then subtract the 3. And I should end up with this standard form of the equation. Okay, and let's go on to the last type of problem here, and that is the word problem. So we're going to do the same thing, write an equation in standard form to model the linear situation. So number 10, a tank is being filled with gasoline at a rate of 4.5 gallons per minute. So that's going to be an important piece of information for us right here. And then the gas tank contained 1.5 gallons of gasoline before filling started. So this means before filling started means that the time is actually going to be our independent variable. So be able to identify the x and the y. So minutes is x and gallons is y. It's always y over x when we do our slope or our unit rate. So that means before filling started is when x, our time, is 0. Y is equal to 1.5. Okay. So I'm going to very quickly go through this because we have our slope is 4.5. We can tell that because it's a rate. And then we have the point 0, 1.5. So I was able to get that from those two things that I underlined. And then I can go ahead and start writing my equation. And so I'm going to use point slope form again. And so y minus y1, here's my y1 right here. There's my x1. Here's my m. So y minus 1.5 equals 4.5 times x minus 0. So I get y minus 1.5 equals 4.5x. And then minus 0 is just going to go away. I'm going to do two things here. I'm going to subtract 4.5x on both sides, and I'm going to add 1.5 to both sides. So I'm going to get negative 4.5x plus y equals 1.5. And there it is in standard form. Okay. Number 11, I'm not going to do the whole thing. I'll just kind of get you started on it, and you can finish it up. A pool that's being drained contained 18,000 gallons of water. After 2 hours, 12,500 gallons of water remain. So this gives us, doesn't give us any slope because I don't see a rate here. But we do have 2 hours and 12,500 gallons. So we have, again, time and our volume. So we're going to call the hours our x, and then the gallons is our y. And so the first sentence says, a pool that is being drained contained 18,000 gallons of water. So I'm gonna, that's gonna represent our y, but what's x? Because it doesn't tell us the time. Well, the way that the sentence is worded, we're gonna assume that that's at the beginning, right? That's at 0 hours. So we have the point 0, 18,000. And then also the point 2, because at 2 hours, it's going to be 12,500. So we're going to use those 2 points to help us write our equation in standard form. So I'm going to subtract y2 minus y1. So that's 12,500 minus 18,000. And this should end up being a negative rate, a negative slope, because it's being drained. So think about what's happening when it's being drained. So when I subtract, I'm going to get, what is that? Negative 5,500 over positive 2. And then dividing it is going to give me a negative number for sure. Negative 2,750, I believe. So it is negative 2,750 gallons per hour. And that's how much is being drained. It's negative because it's losing that much water. So you're going to use a slope and one of the points. I would suggest using something like this because it has the number 0 in it as one of your points. You're going to use that as your slope. So I can call that M. And I can call this x1 and y1. And you can use, remember, either the point slope form or the slope intercept form to help you write this into standard form. And that's all there is to this lesson. Have a great day. Thank you for watching.